Hello, everyone, and welcome to our next session. I have Daniel here from Limechain, and he's going to be talking about lessons learned from building AssemblyScript Runtime. I'll let you take it from here, Daniel.
Thank you for the intro. So, hi everyone. As you already know, this session is on lessons learned from building an AssemblyScript runtime. So I hope that it will be useful to you. Just a little bit about me. So I'm Daniel Ivanov, and I'm blockchain solutions architect at Limechain. And Limechain is a blockchain and DOT development and services company, which is based in Sofia, Bulgaria. And for the several years that we were in the space, we have more than 80 projects that we completed successfully related to blockchain and DOT. So before we go into the specifics, I want to share with you how it all started. So we received 2 grants from the Web3 Foundation on AssemblyScript related projects for Substrate and Polkadot. The aim there was to develop new libraries and provide new tools for developers to use. And the first grant was the development of a scale codec implementation in AssemblyScript. As some of you already know, scale codec is used in Substrate for encoding and decoding data coming from the node to the runtime and vice versa, and in various other places as well. So there were already a couple of implementations of the codec, though we needed an AssemblyScript one for our next grant, which was a grant for developing Substrate Runtime in AssemblyScript as proof of concept. And the runtime was an account-based blockchain, which was able to do basic transfers. So the 2 main goals of the project were to verify that runtimes can be built without using Substrate, and second, to lay the foundations for further development of a framework for alternative Polkadot runtime development. Some of you may think why AssemblyScript though? So there are various reasons that the Web3 Foundation and Limechain chose to go with AssemblyScript. So the first one, obviously, being able to be compiled down to WebAssembly was a must for Substrate runtimes. And the other reason is that AssemblyScript has a syntax very similar to TypeScript. And we know that a lot of developers are comfortable with TypeScript. Unlike Rust, though Rust is very powerful language, it's not an easy language to start with, and whether it's perceived or not, there are entry barriers. So we wanted to tackle that problem. AssemblyScript, another reason is that AssemblyScript has a growing developer community. Although it's not a mature language yet, it's in the progress of being such. And the last reason was that there are already various blockchain and DOT projects which are using the language, so this was beneficial as well. I would like to briefly talk about Substrate and the general architecture. So I'm sure that most of you already know this, but nevertheless, let's go through it. Although Substrate has a lot of components, we can distinguish the 2 biggest ones. We have the Substrate node and its runtime. So obviously this is the oversimplification, but bear with me for a second. So the node handles the peer-to-peer networking, RPC interface, the biggest chunk of the consensus logic, and provides the WASM execution environment for the runtime, along with the storage. The runtime, on the other hand, is responsible for our blockchain business logic, which would be which includes the block production, finalization, applying extrinsics, manipulating storage, etc. So how do we normally develop runtimes? Usually, or in most cases, we are using Substrate. and not to handle only the node or host part, but the runtime as well. We are usually composing our features using the palettes already developed and tested by the Substrate developers and provided by Frame. And in this case, we are not taking care of the low-level abstractions, such as passing data between the node and the runtime, encoding, decoding that data, or handling block initialization and finalization. We are not maintaining account nonces or computing the root of extrinsic. So all of that is handled by the Substrate executive and system and other modules. In other cases, when we cannot find what we want from the palettes already developed by and delivered by Frame or the community, we are creating our own runtime APIs or runtime modules similar to the provided from Frame. So, and again, we are following, when we're developing the modules, we are following the rules specified by the Substrate framework, and we are kind of being kept safe and utilizing Substrate's features. In very rare occasions, developers are hacking on the Substrate core components. For example, changing how data is encoded or decoded, how it's written into storage, or everything related to the more low-level operations requires more technical knowledge of how Substrate operates under the hood, and this makes it time-consuming and error-prone, actually. Going back to our diagram of a Substrate client, as you already know, Substrate supports two types of runtimes: native, meaning in Rust, and a WebAssembly one. The WebAssembly runtime can be upgraded and swapped, etc. So this is one of the biggest advantages that Substrate clients have. However, when we are using the WASM runtime, there are additional components which add overhead compared to a native runtime. For example, the Substrate node exposes a WASM execution environment in which the runtime is executing, or we have we have the runtime APIs and other, and in order for the node and the runtime to communicate. And when we are using Substrate runtime, basically runtimes developed by the Substrate framework, the framework handles those things for us. Scale codec is used for encoding and decoding. Operations for reading and writing into storage are provided basically out of the box, and we are not taking care of block execution, validations for blocks, extrinsics, etc., except for our custom blockchain business logic. We are focusing only usually on, in our diagram here, on the orange boxes that you see there. So, for example, we define the consensus algorithm. Normally, we get it from the Frame library, and we define whether we want assets or balances, etc., treasuries. We decide what features do we want in our blockchain. We could even add our own custom module, as I already mentioned, if there's no palette in Frame for that. So the aim of our project was to verify that WASM runtimes can be developed from scratch without using the Substrate framework, and this is actually what we did. So we basically implemented the whole runtime that you see there in the diagram in AssemblyScript, along with we've implemented not only the palettes that we need for our account-based runtime, but we've implemented the storage, system executive, and the other modules. So the end result is basically this. So this is a screenshot. I hope that it's visible to you guys, but this is a screenshot showing 4 Substrate nodes. 2 of them are validators and 2 of them are non-validating nodes, and they are fully synced together, producing blocks and handling transfers. And all of this is is using a WebAssembly runtime that is not created using Substrate, but compiled down from AssemblyScript. And we actually finished the project this week, so this is brand new. So during our endeavor, what we've learned and what might be helpful to the community is that, first of all, we learned that it's possible to build runtimes without using Substrate, which was the goal of the project. Second, we learned that actually Rust is a very powerful language, which provides the opportunity for building complex software, and it has many advantages, and that's why it was chosen for Substrate. It was chosen for a reason, and Substrate is very powerful as well. While we were building the runtime, we had to spend a lot of time going through Substrate's code base, and the whole framework really impressed us. For example, the way that Substrate uses macros to enable modularity and modifiability is really impressive. All of this shows that, first of all, Substrate core developers really did a great job. And second, that Rust is very powerful. Another thing that we've learned is that when it comes to building runtimes, there is no one place to go to. The resources that you need are scattered across the Polkadot host specification, the Substrate developer hub, and even the Substrate inline documentations. So the Polkadot host specification is a very detailed description on the requirements of a Polkadot host, and you could use that to extrapolate what should the runtime do based on that. In terms of the Substrate developer hub, it has a lot of information related to the architecture of Substrate and its general concepts, so it was pretty useful as well. And the last place that I mentioned, the Substrate inline documentation, when it comes to the really low-level requirements and concepts, this was the place to look at. Because of those resources, we didn't actually need to contact the Substrate developers that much. And we managed to do it only contacting them on several occasions. And to be honest, they were pretty helpful and responsive. We managed to resolve our problems pretty fast. The last thing that we learned is that building runtimes without framework is time-consuming and error-prone. So that's why I want to give you some other tips in case anyone builds a runtime similar to ours. I mean, you could build in other languages such as Go and C++, etc. But this is the approach that we found successful and helpful. So first, start with mocking the runtime APIs and making sure that you have node to runtime communication. Basically, calling into runtime APIs and parsing the data was our first step. And do them one by one. Do not worry about implementing the models at this point. I mean, do not worry about implementing extrinsics, blocks, accounts, etc., because they will change anyway. After that, you could proceed with the storage module, which would basically mean being able to read and write bytes into the node's storage. And this is the point where you should think about modularity as a top priority. We found it very valuable to extract the different modules in different packages, and it was pretty helpful for the further development of the runtime. After that, my advice would be to develop the consensus module. In our case, this was the Aura consensus, because it's the simplest one. Once you have that, you can proceed with the implementation of the state transition function. And this is when everything will come into place. Blocks are going to be produced and you have your extrinsics, etc. So what's next for AssemblyScript and Polkadot and Substrate? Well, we have a rough roadmap here. As you can see, there are 4 milestones, and the first one is already completed, basically the proof of concept runtime. The next step in our roadmap is to reduce the time and effort for building those AssemblyScript runtimes. And this is when Subassembly comes into place. Our plan is to develop Subassembly, which is a framework, which will be a framework for developing AssemblyScript-based runtimes. And now that we have built the proof of concept runtime, we can evaluate what has to be done and which are the important things to get right in terms of building AssemblyScript runtimes. And with Subassembly, we would like to provide the opportunity to developers to build runtimes similarly to how they are built with Substrate. It would mean that you have components off the shelf for various blockchain features, and it could be think of as Substrate for AssemblyScript. Obviously, we are still at the early steps of the framework, and we're currently working with the Web3 Foundation to make sure this will happen and get their support as well. The next step in the roadmap, as you can see, is that we would like to verify that we will be able to build parachains and run AssemblyScript parachains using Subassembly. And similar to the first step in which we developed the proof of concept runtime, we want to build a proof of concept AssemblyScript parachain, gather the required information, and proceed with the end goal of this whole endeavor, which would be to reduce the time and effort for building AssemblyScript parachains, and which would basically mean that our end goal for Subassembly is for it to become a parachain development kit, meaning that we would like to get to the point where Subassembly can be used to develop Kusama or Polkadot parachains, etc. And we think that having such framework will enable millions of developers who already know JavaScript or TypeScript to be able to build on the Web3 stack and drive the whole Web3 vision forwards. Thank you everyone for joining in. I want to thank the Web3 Foundation for supporting us, and as well the Limechain team that's building on top of Substrate with AssemblyScript. And here are 2 links to the two repositories for the Scale codec and the AssemblyScript runtime. And yes, thank you again for joining.
Thank you, Daniel. That was great. I think we have enough time just for one question. We have one here from Joshi. He's asking, what runtime APIs did you implement? Did you have to hack the non-runtime parts of Substrate at all?
Well, we had to implement, so first of all, we had to implement the the version one, which retrieves the version of the runtime. We had to implement the block builder for basically initializing blocks, finalizing blocks, executing blocks. We had to implement the validate transaction API as well. So most of the APIs that were required for us to build the proof of concept runtime, we have built them. So we are able to produce blocks, validate extrinsics, etc. And I think that was the first part of the question. What was the second one? Sorry.
Did you have to hack the non-runtime parts of Substrate at all?
Well, we picked up a node template from the repo, and we just configured it not to use grandpa, and that was basically it. Other than that, we basically added a couple of walks to make everything more informative while we were developing, but not much related to the node.
Great, thank you. That's all the questions we have. But if anybody wants to connect with Daniel further, he'll be on Discord should you have any more discussion to have on Limechain. Thank you, Daniel.
Thank you.
Great. So before we move into our next session, I know we had a planned break, but we're running a bit behind time, so we're going to cancel the break. So we're no breaks this conference today. So our next part is our parallel workshops. We have 4 great workshops lined up for you. Our first one being the build your first blockchain with frames. So if you're new to Substrate and haven't built with Substrate yet, I highly recommend you join this one, where you'll learn how to build your first blockchain with Substrate, and it's going to be hosted by Brian Chin from Akala. He's like one of our great supporters and been building with Substrate for quite a while now. So great person to learn from directly from the community, and he'll be supported by Dan Forbes. So you get to hear that wonderful voice again. The next workshop, if you're a bit more into Substrate, is our Inc 3.0, again with Robin, and he'll be joined by Andrew, and you'll learn the fundamentals of Inc, the program language, including setting up a developer environment and writing some basic intermediate contracts and deploying contracts to a live blockchain. And then the other workshop we have is Parachains. So a little bit more advanced. This is being hosted by Ricardo from our Parity team, and he's going to show you how to convert a Substrate frame-based runtime into a cumulus parachain. And then finally, we have another community-led workshop from PureStake, and this is using Frontier to build an Ethereum-compatible Substrate-based chain. So you'll be joined by Joshi, who actually used to work at Parity and has just recently joined the PureStake team, so we're happy to still have him within the family. Alberto and Timo, all from PureStake, and they'll explain the concept behind Frontier project and a compatible layer that allows running unmodified Ethereum smart contracts on a Substrate-based blockchain. So these workshops are all running parallel. If you just use the drop-down menu, you can choose which workshop to go into, or you can follow one of these links that I've just posted. Before we end, I want to say thank you to everybody that's here. Thank you to everybody who has joined. We wouldn't have this event without you. I want to say a huge thank you to all of our speakers today. They did a fantastic job, and I hope you've learned as much as I have during this conference. We, of course, plan this conference 2 times a year, so keep an eye out for that. And just as a reminder, we've also got Polkadot Decoded coming up on December 3rd, where you can learn more about parachains and parachain auctions and what interoperability means in Polkadot. So be sure to sign up for that event. We will be sending a follow-up email with some more information on how to stay connected with us. One of the easiest ways to continue to learn about Substrate is to join the Developer Hub. You can join via here, but we'll send this also up in an email so you can all keep in touch. Thank you again for joining. I hope you enjoyed your day, and good luck in the workshops.